Welcome to the spoken tutorial on forces. In this tutorial, we will demonstrate resultant of forces and equilibrium of three forces apps. Here I am using Ubuntu Linux OS version 16.04, Firefox web browser version 62.0.3. To follow this tutorial, learners should be familiar with apps on physics. For the prerequisite tutorials, please visit this site. Using these apps, we will demonstrate the addition of vectors, an experiment to show the equilibrium of forces, and how to achieve an equilibrium condition. Use the given link to download the apps. I have already downloaded Apps on Physics to my Downloads folder. Right-click on resultant_en.htm file. Select the option Open with Firefox web browser. Resultant of Forces app opens. You can open the app using any other browser. This is the interface of Resultant of Forces. By default, app shows two vectors drawn from a fixed point. We can click and drag the vectors to change their magnitude and direction. In the green control panel, there is a drop-down to change the number of forces. From the drop-down, we can change the values from 2 to 5. By default, 2 is selected. Click on Find Out Resultant button. Notice that the second vector translates parallel to itself. It is attached to the head of the first vector. Vectors are added using head-to-tail method. Observe that the red vector is the resultant vector formed by addition of two vectors. It is drawn from the point of contact to the head of the second vector. Addition of vectors follow triangle law of vectors. Let us state triangle law of vector addition. It states that when two vectors are represented by two sides of a triangle with same magnitude and direction, then the third side represents the resultant of vectors. Click on Clear Construction button to clear the resultant force. From Number of Forces drop-down, select 5. Click and drag the vectors to change their magnitude and direction. Adjust the vectors to get equal magnitude for all vectors. Then click on Find Out Resultant button. Notice that each vector will get attached to the head of the previous vector. The resultant is drawn as its tail is joined to the tail of first vector and head to the head of last vector. This represents polygon law of vector addition. As an assignment, change the number of forces to 3 and 4. In each case, change the magnitude and direction. Observe the resultant vectors and explain your observation. Now let us explore equilibrium of three forces. To open the app, right-click on Equilibrium Forces_en.htm file and open with Firefox web browser. This is the interface of equilibrium of three forces. Below the name, a short description about how to use interface is given. The hanging weights represent the forces acting on the knot. The green panel shows left, right, and below forces. These forces are acting on the knot to achieve an equilibrium condition. Notice that each force must be smaller than the sum of other two forces. App has measured the left angle as 30 degrees and right side angle as 56 degrees. Let us define equilibrium of forces. When all the forces acting on an object are balanced, then the object is said to be in a state of equilibrium. By default, Parallelogram of Forces checkbox is selected. If we uncheck the box, angles formed will not be seen. Press F5 key on the keyboard to get the default view. Let us change the forces to 6 Newton, 4 Newton and 8 Newton. Note that 6 is smaller than the sum of 8 and 4. And note that 4 is smaller than the sum of 6 and 8. Similarly, 8 is smaller than the sum of 6 and 4. This satisfies the above balance condition. We can change the position of the pulleys using the mouse. Choose 4 Newton for left, right and below forces. Notice that for equal forces, the angle is always 60 degrees. Use F5 button on the keyboard to refresh the app. Change all the forces to 7 Newton and observe the angles. As an assignment, try different combinations of forces to check the angles and equilibrium conditions. Give an explanation. Let us summarize. Using these apps, we have demonstrated the addition of vectors, an experiment to show the equilibrium of forces, and how to achieve an equilibrium condition. These apps were created by Walter Fend and his team. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial project team conducts workshops and gives certificates. For more details, please write to us. Please post your timed queries in this forum. Spoken Tutorial project is funded by MHRD Government of India. This is Himanshi Karwanje from IIT Bombay. Thank you for joining.